even if you want to save this for later, you know what you want to ask now.
What?
Yeah, like
I'll ask you
16 and
later.
20.
Okay. Good question. I'll do them first. I'll do 16 and 20 first, and then we'll go. Do you have them from that?
No.
478. Did I skip it? Oh, crapper. Sorry. I'll get to it.
Yeah, all right, here we are. Curious about them? Everything else. I'll buy it and do whatever you want. Actually, you'll get a lot of money. Yeah.
What is the formula for this one?
Okay, so number 16, it's a Taylor polynomial. And you're going to see a question like this because the open-ended question that you have on the second sheet, there's a question just like this too, where instead of actually giving you the function and asking you to write the Taylor polynomial for it, they're just going to give you a bunch of its derivatives, so you never actually have the function. So they're saying, like, if you have a function where f of 0 is 4 and the first and second or third derivative at 0 is like that, write a Taylor polynomial. Could they give you this information and ask you to write a Taylor polynomial centered at 2? Could they?
Of course.
No. Because they're giving you values for 0, that's the only place they can ask you to center it. If they told you f of 2 was 4 and f prime of 2 was 5, well then I would center it at 2. But if they're having zeros as all my x's, then it has to be centered at 0. So the formula for that polynomial, I'll say p of x, it goes f of 0 plus f prime of 0 times x to the first plus f double prime of 0 times x squared over 2 factorial plus f triple prime of 0 x to the third over 3 factorial. So I'm just using the formula. I didn't draw the formula up here, but it's f of 0, f prime of 0 times x, f double prime of 0, x squared over 2 factorial, f triple prime, x to the third over 3 factorial. So if they're asking you to write a third degree polynomial, I have that because my highest power is 3. That means it's a third order or a third degree polynomial. I would probably clean it up a little bit to make it 4 plus 5x minus 4x squared plus x to the third. If I go 3 factorial, 3 times 2, blah, blah, cancel. Does that make sense? Okay, then they're going to want you to estimate for some value. So now they want you to basically, this is a third degree polynomial for f of x. So f of 0.2 means plug 0.2 into this. So you would take your calculator and do that. Okay, whatever that is, I have it on the paper. You get that number. Is that okay?
How do we know when?
We don't have that.
I didn't actually do it? Oh, sorry. Oh, okay, same thing, I just left it blank. So whatever, plug in 0.2.
Just use your mouse.
Yeah.
Are we going to be able to use our calculator?
Unless, I've seen ones that are no calculator, but the most I've seen you do is square a decimal. I haven't really seen you have to do
Can't do that.
power to the third. Yes,
No,
you
I
can.
can't do that.
Okay, questions? That part should be easy. The harder part is part B. Write a second order polynomial for f prime of 0, which is the derivative of f. Well, the idea that you're supposed to understand is if you have a polynomial for f, and I want to write a polynomial for f prime, I just have to, I can just take the derivative of this, and that'll give me f prime. So I got to take the derivative of this side. I don't know why I wrote dx, but I'll just take the derivative of each. So I can take the derivative term by term of the series, and that's going to give me the whole series as a derivative. So derivative of 4 is 0, so we got 5 minus 8x plus 3x squared. They asked you for a second order polynomial, and that makes sense. They couldn't ask you for anything more than that because I didn't have this defined anything bigger than a third, or a third power. So when I take the derivative and my power is decreased by 1, that's the biggest that I can get. That's it. Yeah.
It's not hard at all.
No.
For the writing the Taylor with starting from the first derivative,
Yeah.
just do it plug in starting with f prime.
Wait, say it again?
Like just do the Taylor series again, but start with f prime.
Oh yeah, sure, you could. Yep. Yep, if you wanted to instead, you could just go from here. Now this is the first term, here's your second, here's your third. Sure.
Alright, that's a lot easier.
And then plug in 0.2 and get f prime of 0.2. Zach, sounds gonna hate you. Is that okay?
You do a good job.
You're kicking it so much.
She puts her blood, sweat, and tears into that every day. A lot of this stuff is a lot easier once you actually just see it done. Number 20. Okay, number 20 is also not that bad, but it's going to seem pretty hard. Okay, so let's see if we can do this. What did I do? I wonder which way would be easiest to do this. Okay, number 20. If this was what I was given, so let f of x equal this function and g of x is this. We won't worry about g of x right away. Part A, write the first 4 terms for the Maclaurin series generated by f. The reason why they're saying Maclaurin is it's just going to be centered at 0. It's a fancy way. They could have just said Taylor series centered at 0, but instead they say Maclaurin for whatever reason. There's a couple things that you could look at here. Did you take derivatives if you did it yourself?
No one did it.
Some people did.
Who did?
Some people.
And why did no one answer your question?
I don't know. Okay.
No one.
There's 2 things that you could look at when you look at this. One is, does this pop out as any kind of particular thing? It's geometric. We could write this as a geometric series and make it pretty easy. Or we can take all of the derivatives. Which would you rather try? Geometric's going to be the easiest way. If you can see that this is geometric, what's your first term? 2. What's the r term? T squared. So if I'm going to write this that way, I'm going to have the first term plus multiply 2 times t squared, multiply it again times t squared, and one more time, and that's it. The first 4 terms given by f, there's your first 4 terms.
But is that still Maclaurin?
It is, all that means is, it's like a power series, meaning it's like a polynomial with powers. So that is fine. If I wanted to do it the other way, it would still work. It's just gonna be a huge pain in the neck. I could say f of 0 equals 2, and then I gotta find f prime at 0. So,
Probably still give me 0.
I gotta take the derivative of that and get negative 2 times 1 minus t squared to the negative second times negative 2t. Right?
Yes.
So this is gonna be
2t squared.
4t over 1
Just
minus
calling it.
t squared. Oh gosh.
But it's 0. So
It's gonna give me 0, but now I gotta find the next one. Now I gotta use quotient rule and power rule at the same time.
holy.
Does it make sense that this one gives me 0? Because this, if I'm gonna write the polynomial for it, this would be my first term. This would be my second term, 0x to the first. So that makes sense because there's no second term with the x to the
Either
first.
not X or T. So yeah.
This one should work. So this one, if I would use quotient rule, oh my god. You know that for sure? No, it's not. Shut up.
should be.
That's what I'll end up being.
I mean, it'll end up like that.
No, well, no, it won't. But like, it should actually end up as 4, shouldn't it? Shouldn't this equal 4?
Yeah,
Because I gotta put it in as 4x squared over 2 factorial. That's the number.
Yeah, but then you cancel it.
I'm just saying.
Well, now we're using
I
x.
easily cancel
So
it.
if I took the second derivative, I'd have like the bottom times the derivative of the top minus the top times the derivative of the bottom.
Change. Over photo.
Over the bottom squared.
Holy.
And I'd have to plug in 0 to that. Once I plug 0 into this, that's gone. When I plug 0 into that, that's 1. When I plug 0 into this, it's 4. So it is 4.
So easy.
But that would have only given me my second term.
Do again.
I'd have to do it again and again and again and again. I have to go 4 more times. Don't do that. Do you understand what I'm doing? That if I were to write this by the definition of a Taylor or Maclaurin series, I'd have to go take all these derivatives and plug in 0. I will get this. Just like just now I got this to be 4. So that would go next, 4x squared over 2, and that would get me back to this term. But I'd have to do it a lot, and it would be gross. So you don't want to have to do that. Think about how little time you have on the AP test. There's no way you want to do that. You want to pull out that that's geometric, and you can write it that way instead. Do you understand? Okay, so that answers that question. The first question just said write the first 4 terms, which I did. And I did it using the fact that it's a geometric series, not taking all the derivatives because that takes forever. Next one, write the first 4 non-zero terms for G. There's G.
You couldn't use 0 terms for A then?
What?
Couldn't you use 0 terms for A?
Can I use 0 as A
Couldn't you get?
for the G of X? Yeah, I guess you could, actually. Well, there's a couple ways to think about this. We can try to go through and get, like, G of 0 is going to be your first term. What is G of 0? What's the integral from 0 to 0? 0. And then the next one, the derivative of G. Well, the derivative of G is the same thing as regular f, and it's over there. But then it's going to start to get dicey. What can we do instead? If G is the integral of f, and this is the polynomial for f, how can I find the polynomial for G? I can just integrate the whole series. So if this is the series for f, and G is the integral of f, I can just integrate the series. So the integral of this series is going to be G, and now I'm going to have 2t. I'll stick in terms of, or say I'll stay in terms of
What
t.
about your plus c term?
I don't need to worry about that. I had it written down, a proof of like y, but I already forgot. Because I thought someone would ask me that last week, and I already forgot. there's some reason. I guess because I have a plus C here and a plus C here and they kind of like cancel each other or something. I don't know.
Sure.
Don't remember. Who cares? There you go. That's it. Okay, first three non-zero terms, that's it. So don't make your life more complicated than it needs to be. Oh, 4, sorry, whatever. That's it, right. Oh, and that says and the Maclaurin series. We actually need to write a rule for this. If it says write the first 4 non-zero terms and the Maclaurin series, it wants like the general term. So we've got a 2, we've got a t to a power, and we've got a number. What's happening to the numbers on the bottom? They're odd, so they're 2n plus 1. My powers are also odds. God bless you. My powers are all 1, 3, 5, 7, and then my dividers are all 1, 3, 5, 7, so...
If we put that on every answer, like, when do we only do that?
If they just want the first 4 terms, you just list the first 4 terms. If this was worded, list the first 4 terms and the Maclaurin series. That tells you to list the first 4 and the general term.
Oh.
Sometimes they'll actually call it the general term.
General term.
Fun! Alright, let's keep going. What'd you say? 10. Let me do this worksheet first, if we have time for it, and then I'll get 10. Even if I end up giving it to you tomorrow, what is 10? Yeah, because 10 should have been pretty easy. I'll get that one up at some point. Alright, how was the... Zach, would you stop it?
That's why I don't like watching your videos when you do it, because I get motion sick from it. Not kidding.
Oh my god.
Son's allowed to punch Zach in the face.
You must have smiled.
Okay. Two of them. Seriously? Oh.
It's not intimidating at all. Like, I got your picture.
You're supposed to get the whole class to leave.
I was resting my eyes, I was paying attention. We're doing number 10 now, right? Are we doing number 10?
No.
We were listening tomorrow.
Number 10 was 30 minutes.
Can we start with the open-ended question? Because I think it's the most important.
Another point
That you're what?
meeting in 5 minutes.
Oh, yeah, he told me. Zach's filming.
Zach, don't be
We
too.
used to be on our tire. We were doing this all night.
Just can you give Jim's face for the rest of the video?
No. No.
Nothing else. That is the music.
I can't do that. No. No. Exactly.
Let's go back and watch the boys. Wait, Zach, you filmed them? He's so good. I'm wild. Not Oh. I usually never want to do
Okay, ready? This is going to show up again. Something really similar to this. So, here we go. They're giving you a polynomial, okay? So right away, even if they didn't tell us this, what do we know that it's centered around? No.
4.
4. Okay, because of all these x minus 4s, it's definitely centered around 4.
That's a
This is a Taylor one, centered at 4. The Maclaurin one is always centered around 0. So if it tells me to find f of 4 and f triple prime of 4, this one's really easy. What's f of 4? 7, okay? That's always the first term. If it was centered around 0, it would have asked you for f of 0, and it would be the first term. So f of 4 is easy. That's just 7. But to find the other one, I don't think it's quite so easy, and you can look and see what I did. But I kind of like went below this polynomial and wrote out the formula so that I could see what the heck I was looking at. For example, like I know that this is f of 4. I know this is supposed to be f prime of 4 times x minus 4, period. This is supposed to be f double prime of 4 times x minus 4 squared over 2. This is supposed to be f triple prime of 4 times x minus 4, the third over 3 factorial. And so on. I only went up to this point because that's all I needed to figure out, f triple prime. So I kind of thought, like, if I'm supposed to figure out what's f triple prime of 4, these two terms are supposed to match. Oops. Does it make sense what I'm trying to do? Why did I put pluses and minuses? That I'm trying to make the Taylor series that they gave me match up to the formula. Because I know that f triple prime of 4 is not just 2. 2 is the result of simplifying the formula. So the formula is, this particular term should have been f triple prime of 4 over 6 times the x minus 4 to the third. And that's supposed to equal what they actually got for that term. See what I mean? So I took the definition, I took the formula, and I'm setting that equal to its partner term in the actual series. So like these I don't need, so to find out what the triple prime of 4 is, it's going to be negative 12.
How do you know that there aren't zero value terms in the series?
What do you mean?
Like, what if f triple prime were actually 0 and they weren't there at all?
Because then the x to the third wouldn't be there. Okay, so that's a good problem that you're going to get at some point. So whatever they ask you for, if they asked you for, this is negative 12, if they asked you for f double prime of 4, well I would have gone to f double prime of 4 is supposed to be this. They reduced it to get 5. Well then what's f double prime of 4 actually? 10. So that it reduced to the 5. Okay, so I kind of went like that. Second question says, write the second degree Taylor polynomial for f prime. So what we just did. Well, if this is the Taylor polynomial for f, then if I want to write it for f prime, all I got to do is take the derivative of this one, term by term. So here's where you need to, make sure you know all your power rules and stuff. The derivative of 7 is 0. The derivative of this term is what? If this is to the first, I'd go 1 times negative 3 times x minus 4 to the 0. So that actually x minus 4 is going to go. My next term's derivative, take my power down, so it would be 10 times x minus 4 to the first. Get it? So I'm just going term by term derivative. My next one, I'm here, will be minus 6 x minus 4 squared. And the next one, the derivative of the last one, 24 x minus 4 to the third. They asked for a second degree Taylor polynomial. This sounds really stupid. They want a second degree. Did I go too far?
Yeah.
Yeah. Don't go too far. I think they might take a point off, which is really stupid. But if they want second degree, only go to second degree. There's my powers too. And I don't need to include the 0. And I don't need to include that. So put that all together. You don't have to multiply it out. That's fine. And then they also asked you to approximate f prime of 4.3. This was a calculator problem, so you would have had a calculator, plug in 4.3, blah, 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 for the answer. Questions? All right, last part of this, part C. Part C is going to force you to come back up to the other parts, so let me leave this here.
See you, Jennifer.
Peace out. Part C wants you to write a fourth degree Taylor polynomial for g of x, which is the integral from 4 to x of f of t dt. Think about this. If they want you to write a polynomial for g of x, Then I gotta figure out what is g of 0 and what's, I'm sorry, it's centered at 4. G of 4 and g prime of 4 and g double prime of 4 and g triple prime of 4 and maybe g...
Have a nice day, sorry.
You too. Shut up. So I gotta go find all these derivatives of g. So think about this for a second. What's g of 4?
0.
0. Okay, the integral of g of 4 is going to be the integral from 4 to 4. So the integral from 4 to 4 is just 0. So g of 4 is 0. What's g prime of 4? Well, if I take the g prime of x, and I take the derivative of this one, what am I going to get? F of 4. Which is 7. We already found it. If I want to find g double prime of 4, well, that's the same as f prime of 4, which I didn't find, but I can. What's f prime of 4? -3. So now I really do need this like correlation between the what they defined my f to be and then what the actual definition of a Taylor series is, so I can match it up. G triple prime of 4 is the same as f double prime of 4. So f double prime of 4 was, we said, 10. And I don't know if I need this or not. The fourth derivative of g is the third derivative of f, which we found already to be -12.
Can you explain how it's negative 12?
Mike was sleeping, don't
I
worry.
was-
Don't even.
I asked Jimbo, and Jimbo had no clue.
Jim was sleeping, don't worry.
That's when I found it from part A, and they give me this polynomial. This is the definition of a Taylor polynomial. If I match up term for term, this is the third derivative of 4, and this is what they're telling me it is. Since these match, I need to figure out how do I get this to be this. Well, if this is 12, 12 over 3 factorial will be the -2. So that's how I know this is supposed to be -12. I don't know if that makes sense, but we went over it before too. So now that I've got all my derivatives, I use the definition. So if I want to write a polynomial for g of x, I have the first term plus the second term times x plus the third term times x squared over 2 plus the fourth term x to the third over 3 factorial plus the next term x to the fourth over 4 factorial, blah, blah, blah. I forget how many they asked me for. Fourth degree.
How do you know what to use for x? Because you use x.
Oh, shoot. I should. I keep forgetting. I'm sorry.
Well,
Whenever
why do you have to use that for x?
it's centered at 4 instead of at 0. If it's centered at 0, you just do x.
Okay.
This is centered at 4. I just keep forgetting. So this should be x minus 4. And then 3, x minus 4, squared over 2. And I think I went and reduced mine. I did, but whatever. Is that okay? You're missing such a great day outside, but I know. Is that a stain?
We should go outside.
Tomorrow we should go outside.
Should go outside every day this week.
Even if you don't want to sleep, we go outside.
I might
That's a
sleep
lot.
outside.
No,
Okay.
Just kidding.
What, any other questions that come out that you want to make sure we get done?
Results yet?
All right, I'll put number 10 up.
Do you have to?
Results.
Uh,
Why not?
I like my computer at my house. It won't break. And I run my bottom. I run my bottom.
Yeah, acquire another one.
I'm saving the bit like it's card and get my laptop. And it's a bit better. I got $425.
And by saving up even the
That's
price.
supposed to be wiring. Yeah. What? What? No. I have to go on my phone.
Yo, my bus driver came an hour ago, but she has a set of coffee.
I wanna make sure I do.
My mom said she would stop at here.
What's that?
I waited there for 7. Forgot to turn the clock forward. She lives across the street.
Zach, stop. The person who's watching, stop watching. Are you guys sending me messages?